Section 19 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. An Expedition to Mount St. Elias, Appendix C. Report on Auriferous Sands from Yakutat Bay, by J. Stanley Brown. Among the specimens obtained by Mr. I. C. Russell during the course of his explorations on and about Mount St. Elias is a bottle of sand procured from the beach on the extreme southern end of Contact Island, Yakutat Bay, and characteristic of the shore material over a large area. This sand was turned over to me for examination, and additional interest was given to its study by the fact that it is from a comparatively uninvestigated region and possesses, perhaps, economic value. For the sample is gold-bearing, and it is said that a color can be readily obtained by panning at many points on the bay shore. Macroscopically, the sand has the appearance of ordinary finely comminuted beach material, but it differs in the uniformity of the size of its particles from beach sand from Fort Monroe and Sullivan Island, South Carolina, with which it was compared. Its mineralogic constituents greatly surpass in variety those of the sands referred to, but are markedly similar to those of gold-bearing sand from New Zealand. At least 12 minerals are present, with an unusual predominance of one, as will be noted later. Through the mixture of white, green, and black grains, a dull greenish-black color is given to the mass. The roundness of fragments is such as usually results from water action, but it is less than that which results from transportation by wind. When put into a heavy liquid, Thoulet solution at a density of 3.1, in order to determine the specific gravity of the constituents, it was found that the sand is made up largely of the heavier materials, for the amount that floated was trifling compared with that which quickly sank. Even the abundant quartz was largely carried down by the weightier ingredients bound up within it, and only a few water-clear fragments were left behind. This would seem to suggest that the lighter minerals are lacking in the neighboring rocks, or else have been carried to greater distances by the sorting power of the water. Among the minerals recognized, gold is the most important, though relatively not abundant. It occurs in flakes or flattened grains from 1/4 to 1/2 millimeter in size. The particles are sufficiently numerous to be readily selected from their associates by the aid of panning and a hand lens of good magnifying power, and if distributed throughout the beach as plentifully as in the sample would, under favorable conditions, pay for working. The flakes in their rounded character show the effect of the agency which separated them from their matrix, a separation so complete that no rock is found adhering to the grains. Magnetite is present in great abundance, and in a finely divided state, the largest grains not exceeding a millimeter in length. It forms by weight alone 15 or 20% of the entire mass, and when the latter is sifted through a sieve of 100 meshes to the inch, it constitutes 44% of this fine material. Crystallographic faces are rare, and though often marred, still octahedrons of considerable perfection are found. Garnet occurs in such profusion that a pink tint is given to a mass of selected grains of uniform size, and its predominance may be considered the chief physical characteristic of the sand. 2 species were noted. One is a brilliant wine-red variety, which, though not nearly so numerous as its duller relative, occurs more frequently in crystals, the trapezohedral faces predominating. The other garnet is readily distinguished by its lighter amethystine tint and its greater abundance. Crystallographic faces are somewhat rare and invariably dodecahedral. In the absence of chemical analyses, any statements as to the exact species to which these garnets should be referred would be largely conjectural. Attention is quickly drawn to the perfection of these minute garnets in their crystallographic faces and outlines, and to their association with rounded fragments of their own kind as well as of other minerals. Have these crystals survived by reason of their hardness or by favoring conditions, or does their preservation suggest the impotency of wave action in the destruction of minute bodies? Among the black heavy grains occur individuals which, except in shape and non-magnetic character, resemble magnetite. On crushing between glass slides, thin slivers are obtained which in transmitted light are green, and which, from their cleavage, pleochroism, high index of refraction, small extinction angle, and insolubility in acid, are readily recognized as hornblende. Two groups of grains were noted, which are distinguishable by slight variation in color. Both are clear yellowish green, but one is somewhat darker than the other. The optical properties of both indicate pyroxene and possibly olivine. Fortunately, a fragment was obtained in the orthodiagonal zone nearly normal to an optic axis, which gave an axial figure of sufficient definiteness to indicate its optically positive character. A number of grains were selected from minerals of both colors and subjected to prolonged heating in hydrochloric acid without decomposition, indicating that both minerals are pyroxene. A few zircons, a fraction of a millimeter in size but perfect in form, were found associated with others rounded on their solid angles and edges. The crystals are of common short form and bear the usual faces in a greater or less degree of development. Pyramids of the first and second order alternate in magnitude. Pinacoid encroaches upon prism, and vice versa. Quartz constitutes by far the largest proportion of the minerals, both in bulk and in weight. It is always fragmental, sometimes water clear, but chiefly occurs in opaque grains of different colors. It is seldom free from material of a higher specific gravity, and is often so tinted as to be almost indistinguishable from magnetite, but readily bleaches in acid. Feldspar is sparingly present, and includes both monoclinic and triclinic forms, whose crystallographic boundaries are invariably lacking. Treatment of the sand with dilute acid produces effervescence, which is not due to incrustations of sodium carbonate. By persistent search among particles separated in a heavy solution, a few grains were discovered which, from their complete solubility with effervescence in very dilute acid, as well as their optical properties, left no doubt as to their being calcite. The mica group has only one representative, biotite, and this occurs most sparingly, though much of the sand was examined, but few fragments were found. Its foliated character renders it easily transported by water and explains its absence from among the heavy minerals. Shaly, slaty, and schistose material forms the major part of the coarser grains. Thin sections from the largest pieces plainly indicated hornblende schist. A region of glaciers would seem to be favorable not only to the collection of meteoric material, but also to the destruction of the country rocks, the setting free of their mineralogic constituents in a comparatively fresh state, and their transportation to the sea. It was hoped that this sand would yield some of the rarer varieties of minerals, but tests for native iron, platinum, chromite, gneiss, and the titaniferous minerals proved ineffectual. Titanium is present, but in such small quantities that it could only be detected by means of hydrogen peroxide. The use of acid supersulfate and the borotungstate of calcium test of Lascaux failed to reveal the presence of native iron. It will be seen from the foregoing enumeration that the sand is made up of grains of gold, magnetite, garnet, hornblende, pyroxene, zircon, quartz, feldspar, calcite, and mica, associated with fragments of shaly, slaty, and schistose character. While the information at hand is hardly sufficient to warrant much speculation concerning the rock masses of the interior, still there is no doubt that the sand is derived from the deconstruction of metamorphic rocks. End of section 19. Recording by Patty Cunningham.